So here's our important idea for this next set. All the rules we learned about finding limits as x approached a certain value still apply when x approaches positive or negative infinity. So in the last section we said the limit of a difference is equal to the difference of the two limits. So notice I've taken this problem, the limit as x approaches infinity of 5 minus 2 over x squared, and rewritten it as the difference of two separate limits. Well, now if you look at the limit as x approaches infinity of 2 over x squared, you can actually think of that as a product. That's 2 times 1 over x times 1 over x. So I can rewrite the limit of a product as the product of the separate limits. That's what's happened here. So my new problem, I have the limit as x approaches infinity of 5 minus the limit as x approaches infinity of 2 times the limit as x approaches infinity of 1 over x times the limit as x approaches infinity of 1 over x. Well, the limit as x approaches infinity of 5 is just 5. Here's my subtraction sign. The limit as x approaches infinity of 2 is 2. And recall from our discussion of the function 1 over x, as x approaches infinity, 1 over x gets closer and closer to 0. So I end up with 5 minus 2 times 0 times 0. It just makes 5. So similarly, I have the second example. You can follow along on your paper. Write this in. I have the limit of a product. I can rewrite as the product of the two separate limits. So 2 over x plus 1 is the same as 2 times 1 over x plus 1. Here I have 5x squared minus 1 over x squared. I separated it into two separate fractions. 5x squared over x squared minus 1 over x squared. So again, the limit of a product is the same as the product of the two limits. The limit as x approaches infinity of 2 is 2 times the limit as x approaches infinity of 1 over x plus the limit as x approaches infinity of 1 is 1. That's how I get those values. Here's my times sign. Here, notice that 5x squared divided by x squared simplifies into 5. So this becomes the limit as x approaches infinity of 5 minus the limit as x approaches infinity of 1 over x squared, which I can rewrite as 1 over x times 1 over x. So 2 times, remember, the limit as x approaches infinity of 1 over x is just 0. So that's how I got these zeros here. And I get 1 times 5 to make 5. So notice that was 2 examples in a row that had a limit of 5. That's just a coincidence. So we're going to return to our big idea that we ended the last slide set with. If I want to investigate limits as x approaches infinity or negative infinity, one way to do that is to consider which term or terms is going to dominate in the expression. Watch this. So this is especially useful when I want to find the limit of a rational function, a function that looks like a quotient or a fraction. So think about here, if I want to let x get bigger and bigger and bigger toward positive infinity, which parts of this fraction matter? Well, the part that's going to matter most in the numerator is 2x to the 5th. And the part that's going to matter the most in the denominator is 3x squared. So the rest of these terms become insignificant. And I can think about this limit by thinking about the behavior as x approaches infinity of 2x to the 5th over 3x squared. Well, that I can simplify. I can cancel x squared from the top and the bottom. And I have a new function here. What happens to 2x cubed over 3 as x gets bigger and bigger and bigger? Well, there's nothing to stop it growing. That limit is actually infinity, or we could say the limit does not exist. So in this case, if we wanted to talk about the horizontal asymptote of this original function, we would say there is no horizontal asymptote because there is no limit of the function as x approaches infinity. Here's a slightly different function. Again, I want to find the limit as x approaches infinity of a big rational function. Consider as x gets bigger, 2x cubed will dominate in the numerator, 5x cubed will dominate in the denominator. So I can consider the behavior of this function, 2x cubed over 5x cubed. That simplifies to 2 over 5, and the limit as x approaches infinity of 2/5 is 2/5. So we would say that this function, this original rational function up here, has a horizontal asymptote at y equals 2/5.